Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about the chapter chemical bonding. Okay, in this session we are going to see a special kind of chemical bond called hydrogen bonding. Okay, let us see about this new concept hydrogen bonding now. The idea of hydrogen bond was introduced by Latimer and Rodebush to explain the nature of association in liquid state of substances like water, ammonia, hydrogen fluoride, formic acid, etc. In these liquid substances, the association of molecules. So, this was explained by this hydrogen bonding. When hydrogen is bonded to highly electronegative atoms such as fluorine, oxygen, or nitrogen by a covalent bond, then the electron pair is attracted towards electronegative atom, and so that results in the formation of a strong dipole. So, when hydrogen atom which is having less electronegativity, if it is bonded with highly electronegative atoms like a fluorine or oxygen or nitrogen in the formation of a covalent bond. We know if two atoms of different electronegativities they participate in the formation of a covalent bond, then the shared pair of electrons will be pulled towards one of those two atoms or the atom with high electronegativity, and thus what happens, slight charges occurs on those two atoms, and thus the covalent bond formed is called polar covalent bond. So this is a thing happens when hydrogen combines with highly electronegative atoms like fluorine, oxygen, or nitrogen in the formation of covalent bond, so they form a strong dipole. Hydrogen attains a slight positive charge on its atoms, and whereas fluorine or oxygen or nitrogen they attain slight negative charge, and thus a dipole or polar bond is created between them. Now, when a number of such molecules are brought nearer each other, the positive end of one molecule and the negative end of another molecule will attract each other, and a weak electrostatic force will be developed. See here, for example, Hx is a molecule formed between hydrogen and a highly electronegative element like fluorine or oxygen nitrogen. So in the place of X, if we consider either hydrogen or either oxygen or nitrogen or fluorine, both the fluorine, suppose if it is fluorine, both fluorine and hydrogen they share electron pair mutually. But out of these two atoms, this fluorine or oxygen or nitrogen being more electronegative will pull the pair of electrons towards it slightly. Because of that, that will get slight negative charge, whereas hydrogen gets slight positive charge. Thus, the covalent bond formed between these two is called polar covalent bond. Now, when such molecules, number of molecules they brought nearer, what happens? The electropositive end of one hydrogen end of one molecule will be attracted by the electronegative end of another molecule, and thus between these two certain electrostatic force of attraction will be created. Thus these molecules will associate together to form a cluster of molecules. So because of these attractions between the molecules, these all molecules will be together like a cluster group of molecules. So here X representing the highly electronegative element like fluorine or oxygen or nitrogen. So because of these slight attractions between the molecules, these all molecules will be held together with certain weak electrostatic forces. These the electrostatic force of attractions between a partially positively charged hydrogen atom of a polar molecule and a highly electronegative atom of the same or a different molecule is known as hydrogen bond. Okay, now we can define the hydrogen bond as the weak electrostatic force of attraction created between the partially positive charged hydrogen atom of one molecule and highly electronegative atom of the same molecule or different molecule is known as hydrogen bonding. See here, If you consider water molecules, we know in the water molecule formation, each hydrogen shares a pair of electrons with the oxygen atom. In that, there will be mutual contribution of one electron from hydrogen and oxygen, and thus they form a covalent bond. So this is a covalent bond. But out of these two, oxygen is being more electronegative. It pulls the pair of electrons towards it slightly because of high electronegativity, and thus it creates slight negative charge on it. So here also if we say it is a covalent bond formed between hydrogen and oxygen, out of these two, oxygen is being more electronegative, it pulls the pair of electrons towards it, and thus it creates a slight negative charge on it. It is called polarity. At the same time, hydrogen, as it is losing its electron towards oxygen, it creates slight positive charge on it. Okay. Now this can be said polar molecule, and this covalent bond formed here it is called polar covalent bond. So this does in happening in all the molecules. Oxygen will get negative charge, hydrogen will get positive charge. Polarity will be created. When these kind of molecules so many they come close each other, then the electropositive end of this molecule, that means hydrogen, will be attracted by the highly electronegative end of another molecule, that is oxygen of another molecule. So between these two, certain attraction occurs. Electrostatic force will be created between these two. Light electrostatic force. This is slight electrostatic force created between the electropositive end hydrogen of one molecule and the electronegative end of another molecule, that is oxygen, is called hydrogen bonding. Okay, these are slight forces between the atoms of different molecules or same molecule. They are called hydrogen bonding. Let us see the conditions for the formation of this hydrogen bonding. The atom which is bonded to hydrogen atom must be highly electronegative. That means when hydrogen, if it is combined with atoms like fluorine, nitrogen, oxygen, only the hydrogen bond can be expected. The electronegative atom which is bonded to hydrogen must have smaller size. So these atoms, fluorine, oxygen, nitrogen, we know as these are having slight, very less size, and hence they have high electronegativity, and thus they form polar bond with hydrogens, and hence they result in the formation of hydrogen bond. The energy of hydrogen bond ranges between 12 to 60 kilojoules per mole, depending upon the type of atom which is combined with hydrogen. The energy of hydrogen bond is less than that of covalent bond. Means it is not much stronger as covalent bond. It is somewhat weaker than hydrogen bond. This is weaker than covalent bond because hydrogen bond is just electrostatic force of attraction created between two different atoms. There is no sharing of electrons or there is no transfer of electrons. Just slight electrostatic force created because of polarities between the atoms, and thus it is somewhat weaker than the covalent bond, and hence we say the energy of hydrogen bond is less than that of covalent bond. Okay, if you see the hydrogen bonding energies in nitrogen hydrogen bonding, the hydrogen bond energy is 8.4 kilojoules per mole. Whereas if you see the hydrogen bond energy in between fluorine and hydrogen, because fluorine is being highly electronegative, the hydrogen bond will be somewhat stronger when compared to the remaining two cases. That's why if you observe here, the bond energy is greater in case of fluorine and hydrogen bonding. Okay, the bond length of hydrogen bond is longer than that of a covalent bond because hydrogen bonding is just electrostatic force of attraction between two differently opposite charged ions, whereas covalent bond is formed by the sharing of electron pair between the atoms. Thus, hydrogen bond is weaker bond and its bond length is greater than that of covalent bond. The OH bond in water molecule is approximately 1 angstrom, whereas OH bond, OH hydrogen bonding length is 1.76 angstroms. So we know in water molecule there is a covalent bond between the hydrogen and oxygen. If the same water molecule, if you see another water molecule, between these two water molecules there occurs hydrogen bonding. So the covalent bond length in water molecule is, if it is being 1 angstrom, the hydrogen bonding length in the water molecules will be around 1.76 angstroms. Means the hydrogen bond length is greater than that of covalent bond. Okay. Now the types of hydrogen bonding. Hydrogen bonding is of two types based upon the atoms from which molecule they are participating. These hydrogen bondings can be classified into two types. They are intermolecular hydrogen bonding and other one is intramolecular hydrogen bonding. So let us see one by one. First let us discuss about the intermolecular hydrogen bonding. The hydrogen bond formed between partially positive hydrogen atom of one molecule and the electronegative atom of different molecule of this same or different kind of substance is called intermolecular hydrogen bonding. Here inter representing different. Intermolecular hydrogen bonding means the hydrogen bond created between two different atoms, different molecules. So it can be defined as the hydrogen bond formed between partially positive hydrogen atom of one molecule and the electronegative atom of a different molecule is called as intermolecular hydrogen bonding. See here in the water molecule, oxygen is more electronegative atom and hence it is created slight charges on this, polarity on this. In the same way, in other molecule also there is it is created polarity. Now, the bonding between the electrostatic force of attraction between hydrogen atom of one molecule and the electronegative atom oxygen of another molecule. This attraction is created. This is called hydrogen bonding. As it is created between two different molecules, it is also called intermolecular hydrogen bonding. Inter representing here two different. Hydrogen bonding between two different molecules is called intermolecular hydrogen bonding. Some of the examples for the molecules which are having or which are exhibiting this intermolecular hydrogen bonding are hydrogen fluoride, which is also called as hydrofluoric acid. In this also, hydrogen atom or electropositive atom hydrogen of one molecule will be bonded with, will be attracted by the electronegative atom of another molecule in HF substance. This bonding is called intermolecular hydrogen bonding. Okay. Another example, if you see water. In the water molecules also, between two different molecules, there occurs attraction between electronegative atom oxygen and electropositive atom of hydrogen of another molecule. And in the same, one more example we can say ammonia. In the ammonia also there occurs intermolecular hydrogen bonding. Okay. Intermolecular hydrogen bonding increases the boiling point and the solubility of the compound in water. So, because of the formation of hydrogen bonding, certain electrostatic force attractions are created between the molecules. Because of this reason, the boiling and melting points of these substances will be somewhat greater than the expected, and even they soluble into water. Intermolecular hydrogen bonding is also responsible for increase in the viscosity. Viscosity means generally to say it is thickness of a liquid. So because of the formation of hydrogen bonds, the viscosity of the liquids also increases. Greater the extent of hydrogen bonding, more will be the viscosity of that liquid. Okay. Actually, the boiling point of water is being more, that is around 100 degrees Celsius. This is because of the hydrogen bonding existing between the molecules of water. Okay. Next, second kind of hydrogen bonding, that is called intramolecular hydrogen bonding. Intra representing within the same. Intramolecular hydrogen bonding means the hydrogen bonding formed within the same molecule. simply to say. Let us see the definition. The hydrogen bond formed between partially opposite hydrogen atom, partially positive hydrogen atom, and the electronegative atom present in the same molecule of the substance is called intramolecular hydrogen bonding. See here, they have shown a certain organic compound. It is named as orthonitrophenol. In this molecule, this NO group is connected to this carbon and this OH group is connected to this carbon. Now, in this NO2 group, there is electronegative atom oxygen, and in this OH group, there is electropositive hydrogen atom. Between these two, certain attraction occurs that we say as hydrogen bond. And this hydrogen bond is formed between the atoms of the same molecule. This is completely one molecule. Within the same molecule, this hydrogen bonding is occurring, and thus this bonding is called intramolecular hydrogen bonding. That means the hydrogen bond formed within the same molecule. Okay, due to intramolecular hydrogen bonds, no molecular associations occur because it is happening within the same molecule. There is no attraction between two different molecules. That's why in the intramolecular, because of this intramolecular hydrogen bonding, molecular association will not occur because it is happening within the same molecule, no relation with other molecule. That's why the boiling points will be remain normal. Of course, the visco velocity, volatility will be high. So because of this reason, as this intramolecular hydrogen bonding occurring within the same molecule and there is no relation to the other molecule, that is why the boiling points will be normal. There will be no increase in the normal boiling points. Whereas because of intermolecular hydrogen bonding means between different molecules, there is increase in the boiling points than the expected. But in case of intramolecular hydrogen bonding, as there is no relation between the different molecules and it is happening within the same molecule, there is no increase in the boiling points. And even the volatility also will be very high for the substances which are having intramolecular hydrogen bonding. Volatility means what? Converting into vapor form below their boiling points. So certain liquids they convert into gaseous form or vapor form below their boiling points. That property is called volatility, and those liquids are called volatile liquids. Generally, most of the liquid they convert into gaseous form or vapor form below their boiling point. For example, if you take water, we know water boiling point is 100 degrees Celsius. But before that, below that temperature is also water will be continuously evaporating, as we know from the water bodies, water will be continuously evaporating. But water there, it is not heated to 100 degrees Celsius. Below 100 degrees Celsius also, water is slowly converting into vapor form. That phenomenon, converting into gaseous form below its boiling point, is called volatility. And those liquids are called volatile liquids. We know water is also now a volatile liquid, but volatility is somewhat less for water. Some other liquids are there which are having intramolecular hydrogen bonding, like for example orthonitrophenol. This is one of the organic compounds. So in this there existing intramolecular hydrogen bonding. The liquids like this which are having intramolecular hydrogen bonding will be highly volatile. They evaporate very easily below their boiling points. Okay, next. Some other examples, let us see for this intramolecular hydrogen bonding. See here, certain organic substances are mentioned. Need not to worry about the molecular formulae. Just you observe how the hydrogen bonding is occurring. If you see, it's called salicylanide. So in this molecule, between the hydrogen atom of electropositive hydrogen atom and the electronegative oxygen atom of the same molecule, this attraction is occurring because of polarity. This is called hydrogen bonding and it is happening within the same molecule. That is why it is called intramolecular hydrogen bonding. Observe in this molecule also it is happening in the same molecule, isn't it? Yes, these are called intramolecular hydrogen bondings. Intra means within the same. Okay. The properties which are explained by this hydrogen bonding, let us see here. One is molecules with hydrogen bonding possess high boiling points and melting points than the expected. Okay, because of the existence of these hydrogen bondings, molecules won't evaporate at the expected boiling points because of the formation of electrostatic forces between the electropositive hydrogen and electronegative atoms. The boiling points will be somewhat greater than the expected. For example, the boiling and melting points of ammonia, water, and hydrogen fluoride are high in comparison to hydrates and other elements of fifth, sixth, and seventh groups. For example, if you see water, it is a hydrate of oxygen, we can say. What are the other elements along with the oxygen sixth group? Sulfur, isn't it? Selenium. They are the elements present in the sixth group along with the oxygen. Now, this is a hydrate of oxygen. What will be the hydrate of sulfur? H2S. It is called hydrogen sulfide. H2Se, hydrogen selenide. So, in this way, they are the hydrates of sixth group other elements. If we compare these all, the boiling point of water is it is very high. It is around, we know as it is 100 degrees Celsius. Whereas for these hydrogen sulfide and hydrogen selenide, which are hydrates of the same group along with the oxygen, these are very low when compared to that of water. This is because of the hydrogen bonding between the molecules of water. Okay. Because of hydrogen bonding, the boiling point and melting points of the molecules will be increased than the expected. Okay. Next, unique property of water. That is because of this hydrogen bonding. What is unique property of water? It is ice. Water and ice are due to hydrogen bonding. The density of ice is less than that of water. So even though ice is very heavier, it is less denser than that of water. That's why it floats on water. And water contracts between when it is heated between 0 degrees to 4 degrees. Means when it is heated, when the ice is heated, slowly it converts into liquid form. So it starts increasing its volume. But after coming to 0 degrees Celsius, slowly it contracts again. Till 4 degrees Celsius it contracts. Means water has its minimum volume at 4 degrees Celsius. The same time we can say it has its maximum density at 4 degrees Celsius. Because of this is because of the hydrogen bonding between the molecules of water. Because of this reason, ice has less density than that of water, and hence ice floats on water. Okay. Solubility. A substance is said to be insoluble in water if it does not form hydrogen bonding with water, and those are soluble in which can form hydrogen bonding with water. So the substances which can form hydrogen bonding with the water are soluble into water, and those substances which do not form hydrogen bonding with the water are said to be insoluble into water. For example, if you say, generally we say polar substances are soluble into water, non-polar substances are insoluble into water. But there are some substances which are non-polar in nature but soluble into water. For example, if you say organic substances like sugar, urea, glucose, these are actually non-polar covalent substances. But water is a polar liquid. So actually, they should not be dissolved into water, but they are very fairly soluble into water, isn't it? We know sugar dissolves into water. Even glucose and urea, these are fairly soluble into water. This is because of the hydrogen bond formation between these substances and water. So here, the substances which can form hydrogen bonding with the water are said to be soluble into water, and those which will not form hydrogen bonding or insoluble into water. For example, see here certain examples are mentioned. Compounds like acids, alcohols are soluble, and the compounds like alkenes are insoluble into water because acids, alcohols are forming hydrogen bonding when dissolved into water, and hence they are soluble. But the substances like alkenes, they do not form hydrogen bonding with the water, and hence they are insoluble into water. Okay, that's about properties of hydrogen bonding. Okay, thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates and recorded videos. So we can visit our website aimstoday.in for online classes, and you can attempt their quizzes. You can watch live worksheets. You can observe there, do it yourself activities, English classes, reasoning classes, coding. This all you can watch from our website aimstoday.in.